All right, so Year 12s. Today is Wednesday, the 22nd of April, and I'm now going to have a go at our next video. This was a student-requested video, but it is an important part of discrete random variables. So this is still part of Unit 2, but this is a bit of a quick, refresher of discrete random variables before we head into our, later Year 12 content. So looking at variance now. Variance, well, what's this? I mean, it's implied with the word. We can kind of make sense of it by reading this definition. Variance is the measure of spread of the probability distribution about the mean or expected value. Okay, I'll read it again. It's the measure of spread. So how spread is the probability distribution? How spread is this data about the expected value or the mean? Well, let's find out what the mean is first, and then we can do that. So in order to do the mean or the expected value, let's do it below. We'll do it roughly here. So I'll use blue. So our expected value, which we've already looked at, which is also considered to be mu, right, or sigma, is equal to, now, the way that we do this, and we've got a formula for it, and I can take you back. It's basically the sum of all the values of x multiplied by their relative probabilities. Right, multiplied, and then you just add them together, okay? So let's go ahead and do that. In fact, I might even copy this right here, so you can see we're using the same definition from our previous video. There. Okay, so that's the formula there. We're going to go ahead and use it now. So this will be, and now we have 0, which is our first value, multiplied by 0.1. Plus 1 times 0.15, plus 2 times 0.4, plus 3 times 0.25. What I might do is I might even just add one more to our example, one more data point or one more value. Thank you, AutoShape. Let's make that a little bit neater. And then we'll go with 0.1. Okay. So back to our example. And again, if you chuck that into a calculator, you'll get 2.1. So what did we just calculate? Well, we calculated the expected value. It's the mean or the average value of whatever x would be given the probability of each of those values, okay? So again, if our probability of getting a 4 was not 0.1, but say 0.9, it's really going to shift the expected value closer towards the 4 because the probability of getting the 4 is very high. So if you have a look at these probabilities and then you weigh that in with each of the values, all right, your average is 2.1. So the average is just after the 2 here. This is where the average would be across these numbers. So let's go back to variance. What's variance? Well, variance is the measure of spread of this probability distribution, right? Each of these values, this one, this one, this one, this one. How spread out are each of these values in accordance with their probabilities? You still have to take that into account. But how far are these values away, each of them, from that mean that we calculated, which was right here, ready? 2.1. How far away are each of those? And that's what we're going to do. We're going to manually calculate it, and that's what we do with our formula. We're going to manually calculate the variance. How far away, right? What's the spread? And that's the definition now. It's the measure of the spread of this probability distribution about the mean. Now, I hope you can realize that a low variance right? If we get a low number with this answer, it indicates the distribution. Oh, I didn't finish off this sentence here. I'll finish it off. Just delete that full stop. A low variance indicates the distribution is more homogeneous. Homogeneous means basically the numbers are closer together. These values, in accordance with their probabilities, they're very, very close together. Okay. Another way you could view it is that if we calculated the variance to be 0, it means that all these values would be the same. Or each of these values multiplied by their probabilities would be the same. So low variance, similar or closer together. High variance, these values would be much further apart in accordance with their probabilities. All right, so let's go ahead and, whoops, I messed that up, didn't I? Like that. We'll put our full stop back in, and we'll go ahead and now calculate variance. So what's the formula? Well, it's in your textbook. It's on page 744. We'll make a straight line here. Let's use black. In fact, I might make a little bit more space for myself. And our now title is now variance. And in blue, I'll write the formula. So the variance of our values is equal to the sum of each of our values, or yeah, it's kind of like the sum, but what it's really doing is we're finding the difference between each of our values or scores and the probability, or sorry, the mean that we calculated, the expected value. We square it. The reason why we square is to ensure this number becomes positive, because we can't have negative numbers here, okay? And then we multiply that by the probability of that particular value. So here's this is a mathematical explanation, but I love this explanation here. Let's have a look at it. It can be described, so this is the variance. It can be described as the square of the difference between each score and the expected value multiplied by their probability. So let's just quickly break it down. It can be described as the square of the difference. That part there, the square of the difference, ready? Let me just do this. That part there corresponds with this. It's the square of the difference between each score, that's each score, and the expected value, that's the expected value. So basically you grab each score, you take it away from the mean or the expected value, and then you square it. After you've done that, you multiply it by its relative probability, which is this part here, multiplied by their probability. So let's go ahead and do that. Sorry, one moment. Okay, so let's do it. Variance. In this case, looking at our table or our probability distribution, the first one's going to be this. I'm just going to write it and you're going to have a look first. 0 minus 2.1 squared times, well, what's our expected value, it's 2.1. Oh, sorry, 0.1. So what do? What I do is I grab each value. So the first value is 0, so that goes here. I subtract that by the expected value, which we got using the expected value formula, square it, and then times it by the probability of that value. Okay. So let's do the next one. We're now going to add that to the next value. And what's the next value? The next value is 1. 1. We're going to take that away from, again, the same mean that we calculated, which was 2.1, square it, times by the relative probability of that value, which is 0.15. All right, let's keep going. We're now going to add that to our next value. So 2, take away 2.1, square it, multiply that by 0.4, because that's the next probability. Add that to 3, take 2.1 squared, times by the probability of 0.25, and then we'll add that to the last one, which is 4, minus 2.1, square that, and then multiply that by the last probability for the value of 4, which is 0.1. Once we do that, literally just chuck it into the calculator, and the variance of this particular probability distribution is 1.19 if you put that into the calculator. So what did we calculate? We calculated the variance being the measure of spread of the probability distribution about the mean. So basically, how spread out are your numbers? Variance is just a value. It doesn't really give you a whole lot of information to work with. All right, and you're going to see in our next video, which is around standard deviation, that standard deviation is just the square root of this value, which will give us a little bit more of an insight into the data that we've got. So I believe that, standard deviation holds a little bit more power. So watch out for our next video.